everyone. Thank you very much for being here. My name is Andrada, and for the past 5 years, I've been with ING Hubs Romania as a DevOps engineer. A bit of context, ING Hubs is part of ING Bank. It's a bank from Netherlands. From what I spoke yesterday with some of the colleagues, it's not really popular here in Switzerland, but it is in many countries in Europe. And the hubs, we deliver software services to the bank and to other entities. We are present as hubs not only in Romania, but in Belgium, Poland, Germany, Spain, Italy, Philippines, quite a lot of countries. So that's exactly what's happening with ING. But in this session, let's leave the propaganda and marketing of the bank. In this session, I'm going to show you and tell you how we go from code to cluster in this organization and how we've deployed more than 10,000 Kubernetes deployments in the last 6 months. So I have a challenge for all of you. The day after tomorrow, when the conference ends and when you go back to your jobs and open the laptops, please start by looking at your CI/CD pipeline. Remember this session and think about what you can implement from this session in your setup. If you do this, you're going to win quite some time to automate more cool features and maybe that very cool stuff that you had in your backlog and in the back of your mind. The agenda is going to look like this. I'm going to tell you a bit about the context, what was happening exactly in the organization and how we got to that point. I'm going to show you the solution layout, so how our pipeline actually looks like. I'm going to show you some very cool features that we make available and other Kubernetes features that we implement. We'll talk about the risks, because the risks is a very important part of our culture as a bank. I'm going to show you a demo, and hopefully we're going to have some time for Q&A as well. Starting with the context. It was 2019 when inside our organization, a technology shift was happening. The stack consisted of GitLab, Jenkins, TFS, and Ansible Tower was being replaced by Azure DevOps and OpenShift. During that time, engineers were creating their pipelines however they saw fit. They were respecting some guidelines and policies, however. A need was identified back then for a more standard deployment practice. That's when the idea to create the King's Road pipeline, because that's how we are called, appeared. Some of the engineers from the original team collaborated with the developers of a tier 0 application from our organization to try to create a POC. If we were successful with that complex application, we could be successful with every other app. In 2020, the Tier 0 application went live in production with the King's Road pipeline. They became our main promoter, and soon other teams started hearing the buzz about the new pipeline. In 2021, the word spread to other countries, other hubs that I told you about, Poland, Germany, Spain, Italy, and people were starting to be interested in this pipeline. In 2022, the next year, we kept growing organically, so many other teams were onboarding their applications to the pipeline. Inside the organization, however, the number of deployments was being reduced to focus on the reliability and resilience of the applications. Some things the pipeline was already providing to them. This was a catalyst that allowed us to grow much bigger in the next years. In 2023, the King's Road pipeline became mandatory in the tribe we are part of. Next year, we reach more than 1,000 onboarded applications that use the pipeline. And lastly, today, we are currently refining and remaking some parts of the pipeline so we can have a more global approach, because that's the next step in how we created the pipeline. So what exactly is this? The King's Road is a set of templates developed for Azure DevOps. Its goal is to automate the CI/CD process of backend microservices of applications that use the ING internal SDK and the service mesh. So our goal is to be used by every application inside the service mesh. Right now, to give you an idea, there are around 2,000 backend microservices in this service mesh. I'll show you a chart of how exactly this number grew for us. started with 1 application in 2020, around 30 the next year, surpassing 100 applications in 2022, going at 400 the next year, skyrocketed to 1,200 applications in 2024, and now we are at 1,400 and something in 2025, and we keep growing. Now let's look at the more fun part, the solution layout. So the actual flow is pretty standard. We build, deploy, and test. For building, the pipeline is tailored around Spring Boot applications. That means that the teams must package their application into a jar with the dependencies, so a fat jar. We then use Maven to do the heavy lifting and actually build the application and the configuration files. For those, we need a special format. I'm going to tell you more about it in the next slide. Then we also built the Docker image, starting with the base image that was approved by the infrastructure team, provided and scanned by them. We inject there the application jar, scan it, and push it into an Azure Container Registry. The deploy template is plug and play. It can be used, So the deploy template can be used with any kind of application as long as you provide the correct input. The correct input means a Docker image, vulnerability-free, the configuration files of your application, and using this, we employ a continuous delivery approach. So there are some policies and gates, manual approvals that must be ticked before you deploy. Right now, in the organization, people are investigating how we can go to continuous deployment. But again, being a bit of a rigid structure, still some work needs to be done in that area. The test template is similar to the build ones. The tests must be packaged into a fat jar. They are then released in OpenShift to run, and the results are being retrieved by the pipeline using a feedback loop. For testing, our colleagues have access to another really nice internal tool. We call it the Conformance Test Kit. This is a tool that can be run on both local and in the pipeline. It can mimic the production environment of your application, so developers can test more accurately their new features. It can benchmark your app, it can run performance tests, and some other very nice features. As I said before, we use a format that we call the configuration zips for the config file, for the config of your application. We use Helm to release the application in OpenShift. And thanks to this, it allowed us to impose a standard format that it's easy for the consumers to create and for us to use. So as a consumer of the Kings Road, you need to provide a directory for storing your certificates and key stores, a directory for storing your application configuration files, and the values YAML file where you have the ability to configure some of the flags. To complement it, we provide the templates directory with templates for all the manifests needed for every object you want to deploy, and the chart YAML with info about the versions and so on. With the pipeline, you can deploy and release on OpenShift your application, but you can do much more. You can separately release the common objects that control the namespace. You can release the certificate, cron jobs, monitoring, and some auto-scaling objects. So those are decoupled from the application. You can just release them one by one. Going to the deployment strategies we have. We made available 2 deployment strategies. The first one is rolling update. So a consumer can release a new version alongside the old one in the namespace. They switch the traffic from the old version to the new one and then clean up the old one. The next deployment strategy is canary. This is the one that we also make default in the pipeline. So with the canary, we make use of a baseline with the old version of the application and the canary with the new version. We then split the traffic between the old version, the baseline, and the canary. We use this approach because we want a fresh replica of the old version, so the teams can do a better analysis of how the new version acts in comparison to the old one, how are the metrics, how is the performance. Using the old version that's already there, it's not really reliable because it's ran for a lot of time, caching, and all that not so nice stuff. If we receive the go for the canary, then this one is scaled up. The baseline is cleaned up. And lastly, we switch all the traffic from the old version to the new one, and the canary is considered the new release. Looking at the features that we make available, so part of the King's Road pipeline, we have enforced features and configurable ones. Looking at the enforced, at Kubernetes deployment object level, so the deployment strategy is hard-coded on rolling update with a max unavailable of 0, because we don't want any possible downtime during the deployment. We also configure affinity rules to accommodate the HA configuration of ING's private cloud. We make sure we have the needed network policies, so we have connectivity to the service mesh. And we also take care of the image pool policy because we don't want to mess up with the internal registry of the cluster. The configurable ones, users can configure their ports, liveness, readiness, and startup probes. They can deploy cron jobs, extra containers alongside the application container. They can also configure scaling of the deployment and of the namespace. They use the horizontal pod autoscaler, which is a native Kubernetes object for scaling the deployment, and the quota autoscaler for scaling the namespace. So what is this quota autoscaler? It's really nice because this is an open source custom resource definition that was created by our colleagues from infrastructure, from ING. This was created to automate a process that many of our engineers found it tedious, the scaling of your namespace. So before using this object, an engineer had to go to a portal, select the namespace, input the new limits, click on apply, and wait for it to take action. Right now, you can configure this object inside your values file of the King's Road configuration zips, and the manifest is automatically applied on your namespace. How does this object work? Based on the memory and CPU utilization of your namespace, it's instructed to make the namespace bigger or smaller. Some other solutions we implement. The pipeline wouldn't be complete without Prometheus monitoring. We do this by using a node or an operator. The pipeline exposes the service monitor configuration to the user, and the infrastructure team makes available the Prometheus implementation. Then the metrics are being scraped, and people can view them in Grafana dashboards. A reliable pipeline provides a good rollback mechanism. For this, we use native Helm rollback. We also automated the certificate creation using Cert Manager. One of the dedicated teams in ING built a layer on top of Cert Manager to accommodate some of our more pretentious use cases. But this is implemented also in the pipeline. Just by activating one switch, you can request a new certificate, get it signed by the ING PKI, and then apply it to your application right away. We also use PIFI certificates, important mention. For the many policies that we have in place, for some of them we use Open Policy Agent. And we also make available virtual machines deployments with Ansible. Because not everyone, unfortunately, can move their application from a container to a virtual machine. So for this, we enabled the use of Ansible. Last features I'm going to show you, because we couldn't have reached 1,400 applications without supporting some particular use cases. We have an auto-patching feature. So the deployment lifecycle in our organization is 30 days, meaning that even if you didn't make any changes to your actual app in the last 30 days, you have to deploy in order to use a new vulnerability-free image. This obviously was identified as a toil by our users, so we thought to help them out and implemented this really nice feature. Basically, it automatically detects your last production environment, takes the configuration and jar from there, builds a new Docker image, injects it there, releases it into the OpenShift cluster with a minimal amount of clicks from your site. The next one is the configuration-only deployments. So sometimes incidents can be created due to wrong configuration. Most of the times, those same incidents can be resolved with the proper configuration. This is exactly what this feature does. It allows you to use an already existing Docker image that has your application from the Azure Container Registry. You just create the new configuration, put everything together, pack it, and release it in OpenShift. We also make sure that people can deploy application bundles. So they can release applications with, of different flavors and configurations in the same namespace at the same time. We also created a standard playbook for our Ansible users. They can use this in the beginning of the process of deployment and tailor it for their own needs. And lastly, the custom base Docker image, the custom Docker base image, sorry. So not everyone can use the service mesh from a global organization, and not everyone uses Java, which is actually a nice thing because we get to do this sort of features for users that are not really in, the perfect user playbook that we have. This allows them to use their own base image, again, as long as it's vulnerability-free and approved for infrastructure, depending on what their application, in what language their application is written. Last, the risks that we encountered and how we dealt with them. So I would define our organization as one with a very strong risk culture. Staying in control of the risks that your own applications can create is very important to remain reliable to the customers that we have. We contribute this in the pipeline with some checks of validations using Python. We make sure that the application resources and limits are equal because we don't want Kubernetes killing off pods because they consume too much memory. We make sure that the deployment branch of the application is a stable one, a main or the release one. We also make sure that the last commit on that branch is approved and reviewed by a secure code reviewer. We make sure that the base image, obviously, is approved by the infrastructure team. And last thing, because the happy flow isn't always the case when you deploy to prod, sometimes some deviations might appear. Sometimes you really, really have to make your deployment from a bug fix branch. But this kind of deployment will fail because that's not a stable branch. In this case, we enabled the break the glass functionality. Again, another manual validation where you have to justify exactly what you're doing. All the managers are then informed, and then you have to explain everything to them again. But hey, you get to deploy your fix and hopefully fix the incident. We don't only use Python. I've mentioned before that we use Open Policy Agent. We created a Python framework to properly assert the Rego policies natively inside our pipeline. Some of the checks we do, we verify the internal SDK that the applications are using. They have a supported window that we also need to respect. We verify the Kings Road version people are using for taking care of our support window. And we verify some of the application configuration flags. We expect teams to use certain configurations to properly mitigate some possible risks. Now for the fun part, the demo. Before I get to this, please raise your hand if you ever had to do a demo in front of an audience, a live one, and something broke. That's why I'm going to show you a recording. Is this this? Okay. So I'll need to do some setup because I also want to be able to see on my laptop the video.
You can see it otherwise over there.
Hmm?
You can see it over there as well.
I don't have my glasses and it's too small, sorry. Okay. Is it visible? Yes. Okay. Maybe we can turn a bit the lights because it's the black screen. Is it okay in the back? Can you properly see it? Okay, thank you. So this is how the pipeline actually looks like in Azure DevOps. We have, in this case, we have a stage for the checkmarks, code, and vulnerability scan. Kudos to the sponsor of this event. Here, it has failed. It's a mock application. We don't get concerned with that. It's not going to prod, so don't worry. The next stage is used for building and publishing the application. So this is where Maven happens, does the heavy lifting, and then everything is published as an artifact in the pipeline. So it's later consumed by the next stage, which is building the application Docker image and any additional Docker images that we need. In this case, I have two jobs. The first one builds the application Docker image, and the next one, the cron job Docker image. And now going to the biggest stage. Yes, I know it's intimidating. There are a lot of jobs, but I promise you all of them are they have a certain purpose. This is how the canary deployment looks like. We start by checking what exactly exists on the namespace to see at what version we are. We then do the release the canary and the baseline versions. This usually takes the most. Then we start changing the weight. We have manual validations for each change, but we start by incrementing with 5%, let's say, weight on the canary and baseline. We approve, we go to the next one, which is around 30. We approve, go to the next one, and so on. If everything is okay until now, we proceed to scale up the canary, as you see right here, and to clean up the baseline. So right now, I am in the scenario where I have my old version with some traffic and the new version of the canary. I begin to switch, to move all the traffic from the old version to the canary. And if everything is okay until that point, my analysis is good, the metrics are okay, I can consider this as a success. But before I do this, I have an important gate that, in my case, it succeeded with issues. This is the job that verifies how long you stayed in canary. So if this was a production deployment, this would have enabled break the glass, because we are required to stay in canary for a certain amount of time. So the analysis that the teams do is accurate. In my case, being a test deployment, we just passed it, but this is a very good gate that we have in this case. In the end, we scaled down the old version, and everything is switched to the new one. Okay, sorry, I went a bit. This is how the YAML pipeline looks like. This is one with the minimal required parameters. You can add much, much more parameters. First template we're looking at is the build up container. This is the one that does the security scan, building, and the Docker image part, as I'm showing here. So that one is the wrapper around those three templates. So you can call just one instead of calling three. And the next part of the code is the actual release template. Again, minimal required parameters. Service connections, secret management. This is the block where we define each environment. So we define that I want to go to the test environment. I want to go on that data center. I give it the service connection, and so on. Very important here, I have set a scaling replica of 2 replicas. You'll see in a minute why this is an important note. And the last block here is how I tell the pipeline which component I want to deploy. I want to do the application, the certificate, the auto-scaling, maintenance, which is the cron job, or the monitoring. And now, in a moment, we're going to go to the terminal and show you actually some things that happened. So on the right side, I set a watch on the resource quota object from the namespace. So this is the object that gets manipulated by the quota autoscaler. we can see in a second that in the beginning, I'll only talk about the memory resource because I think this is the most relevant one. So I had 0. Yeah, I'm making this so you can see better. At the very beginning, I had 0. So now memory used, no CPU used. I started rolling out my deployment, and slowly this usage started to increase. I can see down a bit that even during this time, my namespace got scaled down because it stayed quite a lot at 4 gigabytes limit. Nothing happened. Quote Autoscaler figured that out and said, OK, I'm going to scale it down. But then I come with my deployment, and the usage started going up. So I see that I reached my limit, 2 out of 2 gigabytes, and it slowly started to increase it. I go to 5. As a fun fact here, I think it's going to be shown in the next terminal. My limit for this was 15 gigabytes maximum of RAM. So in the next part here, I'm showing you a bit of the events of the certificate. I cannot show you, for obvious reasons, how a certificate actually looks like, but we can look at what happened on the namespace with the magic of Cert Manager. So we sent the certificate request to the issuer. It has been approved by Cert Manager. And lastly, we see that it was fetched from the issuer successfully. Next, we look at the certificate object. It was identified that the secret, which will contain the certificate, doesn't exist right now. Some other things happened. And lastly, we see that the certificate has been successfully issued. Here, I'm doing a get on the secret. I confirm that it's here, it exists. And because my pipeline later didn't fail, I know that the application started correctly, and it is able to use the new certificate. Going to the quote autoscaler, this is how my object on the namespace looks like. I'm only showing the most important spec part. So I have defined scaling down and scaling up policies. In this case, my quote autoscaler is scaling down the namespace if the memory or CPU utilization is less than 65%, and I'm scaling it up if it's more than 85%. Again, my screen was being funny. The maximum CPU that I have defined is 8000 millicore with 15 gigabytes of RAM. And the minimum amount is 2 gigabytes of RAM and 1000 millicores. I'm also showing you here the horizontal pod autoscaler object. Very cool, very interesting object, very hard to understand if you try to read the Kubernetes documentation. Trust me, I tried to look at that algorithm. But what happens here? So I have defined my minimum pods from the deployment is set at 3, and the maximum pods is set at 10. This is important because if we look right here, I already hard-coded in my pipeline that I want 2 replicas. I want to start with 2. When I did the deployment, however, the horizontal pod autoscaler looked at it, said, hey, you have 2 replicas. I know you have to have a minimum of 3, so I'm going to scale it up to 3 automatically. Then this is what the HPA actually uses to decide how to scale up and down. The first value of the targets is for memory usage, and the second one is for CPU usage. So basically here, if the memory consumption of every pod in your deployment is above 70%, or the CPU consumption of every pod in your deployment is above 85%, the HPA is going to scale up your deployment. If it's below, it's going to scale down. Okay. Last thing I'll show you here is how easy we do a Helm rollback to one of our components. Here I did it for the maintenance one, so the cron job. We see that it didn't take a lot of time, only 33 seconds, sometimes even less if Azure cooperates with us. And we can see here by looking at the history that we are at revision 3 of the maintenance chart, which is actually a rollback to revision 1. So this was it for our demo. To wrap things up, doing a small recap. So the Kings Road pipeline is a set of templates developed for Azure DevOps to ease the CI/CD process of applications in the internal service mesh and SDK. We offer build, release, and test templates. We are using and implementing Kubernetes objects like Prometheus, Cert Manager, Open Policy Agent, and many more. We make a lot of cool features available to users to improve their lives and reduce toils. We also use Python to do most of our automation in the pipeline. The users can configure a lot of scaling objects. They can deploy cron jobs, extra containers, and so on. As I said at the beginning, the day after tomorrow, when you look at your CI/CD pipelines, ask yourselves, can you implement something from this solution for you? Thank you.